Okay, let's look at question 3 of the chemistry paper. So it says the melting point and boiling point of 4 straight-chained alkanes are shown in the table below. So we've got pentane, hexane, heptane, and octane. Okay, and then they've given us the different melting points and boiling points over there. So 3.1 says define the term melting point. Okay, so you guys just need to go and check your definitions. They want you to do them word for word, so make sure you all know how to do your definitions. Okay, I'm going to focus from 3.2 onwards. So 3.2 is write down the general conclusion that can be made about the melting point and the straight chain alkanes. Okay, so what they're asking for is the relationship between the melting point and the chain length. Okay, so let's have a look what's happening. Okay, the first one is pentane is 5 carbons. Okay, so pent is 5, hex is 6, hept is 7, and then oct is 8. Okay, so as the number of carbons increase, what's happening? My boiling point for pentane is negative 130 degrees. Okay, then it goes to negative 94 degrees, then negative 90 and negative 57. Okay, so those numbers are getting bigger. Okay, they're coming closer to 0, therefore they're increasing. So as my chain length increases, my boiling point increases, therefore they are directly proportional. Okay, so you can then conclude that your chain length is directly proportional to your boiling point, where because as your chain length increases, your boiling point is increasing. Okay, now 3.3 says name the type of van der Waals forces between molecules of octane. Okay, so I've drawn out octane over there. You can see we've got carbon-carbon bonding, and then we've got carbon-hydrogen bonding. But what do we notice? We can't find a distinct positive side and a distinct negative side. Therefore, this is non-polar. Therefore, which van der Waals force are we dealing with? We're dealing with London forces. Okay, because it's non-polar. Now, 3.4 says write down the predominant phase. Write down the predominant phase of the following alkanes at negative 100 degrees. Choose gas, liquid, or solid. So pentane, okay, so pent has a boiling or melting point of negative 130 degrees. So at negative 130 degrees, okay, it's going from a solid to a liquid. So therefore, if we add 100 degrees, negative 100 degrees is greater than negative 130 degrees. So therefore, we are going to be in a liquid phase. Okay, now 3.4.2 says what's happening to octane at negative 100 degrees. So octane has a melting point of negative 57 degrees, okay, which means it only changes to a liquid at negative 57 degrees. So therefore, at negative 100 degrees, that's still greater. We're then dealing with a solid. It's less than, okay, therefore we're dealing with the solid. Okay, now 3.5 says hexane is now compared to 2,2 dimethyl butane. Okay, is the molecular mass of hexane greater than, less than, or equal to 2,2 dimethyl butane? Okay, so I've drawn out both of them over here. Okay, so hexane, 1, 2, 3, 4, 5, 6 carbons. And then if you count up all the hydrogens, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, now let's have a look at 2,2 dimethyl butane. Okay, we've still got 1, 2, 3, 4, 5, 6 carbons. Okay, we've got 3, 6, 9, 10, 11, 12, 13, 14 hydrogens. So therefore, is its mass going to be greater or equal? Well, these two are equal, so therefore the mass is equal. Okay, give a reason why. They have the same molecular formula. Same molecular formula. Okay, so one is just an isomer of the other. Okay, now 3.5.2 it says, is the boiling point of 2,2 methyl butane higher than, lower than, or equal to hexane? Okay, so how do we determine this? So normally we'll first look at the structure, the intermolecular forces, and then the energy. Okay, because if you look at 3.5.3, it says fully explain your answer. So in this case, it's going to be lower than. Okay, so it will have a lower boiling point. Okay, you should pick up immediately because its longest chain length is only 4 carbons, whereas hexane is 6 carbons. So the chain length has decreased, plus we've got 2 side chains there. So how do we go about giving a full explanation of that? So talk about the structure. Okay, so we can see that if we talk about 2,2 dimethyl hexane, sorry, butane. Okay, if we talk about its structure, it's got more side chains. So okay, it's also got a longer, shorter carbon chain. Okay, now we look at the intermolecular forces. So we're still dealing with London forces because we still can't pick up the exact polarity of it. Oh, it's actually non-polar because it doesn't have a definite positive or negative sign. So it's still dealing with weak London forces, or weaker London forces, for its intermolecular forces. And lastly, for the energy, because it is weaker forces, it needs less energy. Therefore, because it needs less energy, it has a lower boiling point. Okay, and that's how we go about doing question 3. Okay, so not too difficult chemistry question this one was. Okay, so if you guys are enjoying the content, then please leave a thumbs up on the video. It does help me out quite a lot. If you are enjoying the content, then do consider subscribing to the channel and click the bell notification so that you guys are notified every time a new video comes out. If you have any questions regarding any of the questions in this chemistry paper, leave them in the comment section down below. I'll get back to them as soon as I can. And remember, it's never too late to have an OIC moment.